All right, so now we're gonna just apply the base angles theorem. So you're gonna be presented with problems that are just like, you're gonna have these triangles that have markings such as this, right? And just based on the fact that we know that this is an isosceles triangle, since A, B, and C, B are congruent, well, the base angle theorem says, well, 52 and that angle have to be congruent as well. So it's actually really easy to find y. Y is just 52 degrees, right? Base angles theorem. All right, and then to find x, we say, well, hold up, people. Triangles just add up to 180 degrees. So all I'm going to do now is say 14x plus 6 plus 52 plus 52 equals 180. All right, and then I'm going to say 14x plus 110 equals 180. Subtract 110 from both sides. 14x equals 70. Divide by both sides by 14, and x equals 5. All right, that's it. All right, use the base angles theorem. Y is easily 52. Then you use the triangle sum theorem and say all the angles add up to 180 and find x. All right, a little smiley face, so happy. All right, this problem right here, it gave us just two angles. All right, it says solve for x, then find the measure of the vertex angle. So this is an isosceles triangle. Not that we really need to know anything about the sides, but we know that these two angles are congruent. Since they're congruent, we're going to just set them equal to each other this time. All right, these angles are the same. And then from here, I'm going to subtract 4x from both sides. As I solve for x, I'm going to get 12 equals x minus 3 plus 3 to both sides. 15 equals x. All right, so again, just applying the base angles theorem. Pretty cool stuff. All right, we'll put a bigger smiley face because that one was really cool. All right, ooh, this problem's quirky. We got all kinds of things going on right here. Well, I gotta find the values of x and y in the picture below. Kind of quirky. What do I do? Well, let's just focus on one triangle at a time. All right, well, this triangle right here, I seem to have the most information. I know the vertex angle is 50. Well, what else do I know about this triangle? Well, I know it's isosceles, so that means that x is a base angle, and in fact, this angle is x as well. All right, because base angles are the same. Well, that means 50 plus x equals 180. 50 plus 2x equals 180. Subtract 50 from both sides. We're going to get 2x equals 130. And then 2 times x, so how do I undo multiplication? I divide, and x equals 65 degrees. All right, 65, so on and so forth. All right, well, cool, I found x. Now, how do I find y? Well, y, there's actually a couple ways to do this. Do I want to do it the hard way? Or I'm going to do it the hard way. There's an easier way to do it, but I'm going to do it the hard way just to force you guys to use the base angles theorem again. All right. There's a quicker way, but sometimes it's good to practice the new stuff. All right. We have a linear pair. All right. If x is 65, that means that this angle right here is 115. Similarly, this triangle is an isosceles triangle, so these base angles are the same, so this is also y. So I have y plus 115 equals 180. 2y plus 115 equals 180. 2y equals 65. What's going on now? I was having a little brain fart. Nope, never mind. 32.5. Okay, there we go right there. Cool. All right. So x equals 65, y equals 32.5. And then let's do this one last problem for this video, and then we'll finish the rest in another video. All right, so and I like these problems right here, 3 to 4, because they're just so not much going on, but you have to use logic. You have to look at markings such as this. All right, like what's going on? We just got these two triangles bashed together. Well, if I focus, I have an equilateral triangle. All right, so that means all the angles are the same, so x is quickly 60 degrees. All right, so what's really cool is that by markings, I saw equilateral, I knew equiangular, I knew all 60. Then by looking again, I see a linear pair, so I know that this is 120. By looking some more, I see, wow, we have another isosceles triangle over here on this side. So I know that this must be base angles are the same, so that's z as well. So little computation over here. And if you guys ever notice, I put dashes through my z's so I don't confuse them as 2's, because z's and 2's look very similar. A bunch of math happens, and you would not believe it, z equals 30. All right, so what I like about these problems, not too much calculation, but more just logic and applying stuff we know. All right,